I suppose I now know the feeling of what you guys feel like. Sweet, I'm finally to the last page. So this page I thought was going to be straightforward, but, you know, in the heat of the moment, your brain sticks in things that doesn't really say. So people were on the lookout for differential equations and separating variables, which is good, but that's not what it says at the beginning. This says consider the differential equation dy dx, so this tells us slope, equals negative 2x over y with the initial condition f of 3 is 4. There are some people that switch that around. Hopefully you know this is the ordered pair 3, 4, as in x equals 3, y equals 4. A non-zero number of people did x equals 4 and y equals 3, whatever. So our first task is to estimate f of 2.9 using a linearization. To me, all that says is make a tangent line. Well, it's a little hard, or at least maybe your brain says it's hard, because we don't have an equation f. But that actually makes things easier. We want a tangent line to f at x equals 3. So what I'm already thinking is I want y minus the y value, oh, I already know it's 4, is equal to slope times x minus the x value, 3. So all I need is slope, but dy dx, that already is the slope. So I don't even have to take a derivative. I need to use the derivative I was given. So I'll do dy dx evaluated at the point 3, 4, and that's going to give me negative 2 times the x value 3 over 4. Or I could say dy dx is equal to divide 2, negative 3 halves. And so now my tangent line to f at 3 is negative 3 halves of x minus 3. So I want to estimate f of 2.9 using a linearization. I'm going to put 2.9 where this x is, and I also want to add 4 to both sides. So you do that in 2 steps. I'm not going to. Let's see, what do I want to say? I want to see f of 2.9 is equal to, well, I'd add 4, so that's going to be 4 minus 3 halves of 2.9 minus 3. By the way, that's good enough. There are quite a few people that subtracted 2.9 minus 3 and got 0.1, which, I'm realizing this should be f of 2.9 is approximately. If you do go ahead and simplify, slow down. You know what you're doing. That's going to be 4 minus 3 halves of negative 0.1. So if you do simplify, you end up getting 4.15. What is that? 3 over 20, 4 and 3 over 20, or something like that. When you get to the second part, when it says find the particular solution, that's the one where we're going to separate variables. Now, there are plenty of people that did all their work and they're like, I meant down here. Totally good. Like, you did all the work. I know what you're doing, but I think, you know, that is feedback for you as well. Like, oh, you knew what to do, but you didn't know when to do it. Okay, whatever. It's a long semester. We got it. So what are we going to do? Well, maybe I'll rewrite dy dx is equal to, is it negative 2x over 3 or negative 3x over 2? Negative 2x over y. Okay, and then it says based on the initial condition above, and that was f of 3 is equal to 4, so I'm going to use that later to fill in my plus c. Okay, showing the work that leads to my conclusion, I know I need to separate variables. Now another thing that an unbelievable amount of people did not do was algebra correctly. You know, if you multiply both sides by y, you get y times dy. A lot of people left it as 1 over y, like they magically transferred 1 over y to both sides. Anyways, is equal to negative 2x dx, so the integral of y dy is equal to the integral of negative 2x dx. Y squared over 2 is a good antiderivative for y with respect to y, and then that's going to be negative x squared over 2, and we need a plus c. Right now, according to my brain, you know, I want to find the c, and right now the c is all on its own. So I'm going to say using f of 3 equals 4, I get 4 squared over 2 is equal to negative 3 squared over 2 plus c. And so 8 is equal to... Do I have that backwards? Gosh darn it. Y squared over 4. What's going on in my tiny little brain? Well, I must be tired. How about the derivative of negative 2x is x squared? So down here, that should be negative 3 squared. Gives me negative 9 plus c. And then again, an unreal number of people saw 8 minus 9 and wrote negative 1, but turns out, and we'll do the algebra because it's been a while apparently, 17. That's what's equal to c. So then basically we rewrite this part, y squared over 2 is equal to negative x squared plus 17. And what we need to do is get y equals. So we'll say y squared multiplied by 2 is negative 2x squared plus 34. There are plenty of people that didn't distribute. Great idea. Take the square root of both sides, and you get y is plus or minus the square root of negative 2x squared plus 34. Now, it happens to be that we choose the positive version. I think plenty of you got lucky and forgot to check the negative. But you might be wondering, well, how do I check the negative? And the answer is we're supposed to get f of 3 is equal to 4. And so hopefully you can tell, if I put a x equals 3 in here, the only way I'm going to get a 4 on both sides, or really a 4 on the right-hand side, is have the plus sign, not the minus sign outside the square root. Right? Because what? 3 squared is 9, negative 2 times 9 is negative 18, plus 34 is 16, square root of 16 is 4. I don't want negative 4, I want positive 4. I hope that helps.